I hope you're able to see, right? Listen. So what was the last topic we discussed? Can someone respond? What was the last point we were discussing? I think we were doing some problems, no, from vectors. So listen. So we discussed what are position vectors. Guys, if you're not going to respond, I'll just keep telling. Okay. I'm not going to waste my time asking you whether you have understood or not. If you have doubt, better you stop me. Or else I'll keep telling, watch the recording and learn. So any vector with origin as the starting point is called a position vector. So if I take this point as P, from O if I join to P, then OP vector is called as the position vector of point P. Right. So if I have find vector joining 2 points, then what I need to do is I need to take one point as A and other point as B. Suppose I take this as OA vector, and if I take this as OB vector, and if I need AB vector, right, then what I will do is I will apply the triangle law of additions, where OA vector plus AB vector is going to give us OB vector, right? OA vector plus AB, because OA and AB are continuous vector, will be equal to OB vector, which implies AB vector is equal to OB vector minus OA vector. So OB vector minus OA vector, that is the final position vector minus the initial position vector. Right. So this is how the vector joining 2 points is related to its position vectors. It is defined as OB vector minus OA vector. And to understand this, let us do the example number 10 from your textbook in page 438. Right? So find the vector joining the points P, 2, 3, 0 and Q, -1, -2, -4, directed from P to Q. That is, we need to find PQ vector, which is going to be OQ vector minus OP vector. Right? If you see what is OP vector will be equal to 2i cap plus 3j cap, and OQ vector is going to be minus I cap minus 2j cap minus 4k cap. So OQ vector is minus I cap minus 2j cap minus 4k cap minus what is OP vector? It is 2I cap plus 3j cap. So this is going to be minus 3I cap minus 5j cap minus 4k cap. Right? This is going to be the value of PQ vector. Next. The next is section formula. So when I talk about the section formula, I have O, let us say I have three points A, B, C. Or I will take like this one. Take this as B. So if I have to join this A to C, right? And I'm saying there is a point P in between, which is dividing AC in the ratio M is to N. Then if this is going to be OA vector, this is OP vector, this is OC vector, then OA vector's position vector, I'll call it as A vector, and OC's position vector, I'll call it as C vector, and OP, I'll call it as R vector. Right. Now, if you see this, then R vector is given as M times opposite, that is M times C vector plus N times A vector divided by M plus N. And this is going to be the section formula for a point which is dividing the 2 points A and C internally. If there is a point which is on the line of AC internally to A and C, means with respect to point P, one point should be on the left, the other point should be on the right. Right. Then this is going to be the formula, and this is called as internal division. Now, there is a scenario where there can be an external division also taking place. If I take this to be AB and there is a point P, which is dividing AB in the ratio M is to N. Right? If I take P to be R vector, B to be B vector, and A to be A vector, then R vector will be equal to M times A vector minus N times B vector divided by M minus N. This is the formula that is used when there is an external division. So I'm not showing you the derivation because everything is derived using the triangle law of addition only. So there is nothing for me to show, and it is not important also. That's why I don't want to waste time. So it is based on triangle law of addition. Okay. Now, the next question is, we will do example 11. So example 11 is, consider 2 points P and Q whose position vectors OP vector is 3 times A vector minus 2 times B vector, and OQ vector is equal to A vector plus B vector. Find the position vector of a point R, which I'll call it as R vector, which divides the line joining P and Q in the ratio 2:1. So one is internally, second is externally. So if I take case A, there is a point P here. This is PQ, this is R. So R is dividing PQ in the ratio 2:1 internally. OP is given as 3A vector minus 2B vector, and OQ is given as A vector plus B vector. So R vector will be equal to 2 multiplied with A vector plus B vector plus 1 multiplied with 3A vector minus 2B vector divided by 2 plus 1, which is going to give us 3. So 2A vector plus 3A vector is going to be 5 times A vector plus 2B vector minus 2B vector is going to be 0 times B vector by 3. So it is going to be 5A vector by 3. So the position vector of R is 5A by 3 when it is dividing the points P and Q in the ratio 2:1 internally. This is for the internal condition. Similarly, when the same point is dividing PQ ratio 2:1 externally, and if I call this as R vector, then R vector will be equal to 2 into 3A vector minus 2B vector minus 1 into A vector plus B vector divided by 2 minus 1, which is 1. So 6A vector minus A vector is 5 times A vector minus 4B vector minus B vector is minus 5 times B vector, the whole divided by 1. So 5 into A vector minus B vector is the answer. So sorry, I made a mistake. A into so R vector is equal to 2 into A vector plus B vector minus 1 into 3A vector minus 2B vector divided by 1. So 2A vector minus 3A vector is minus A vector. Right? So 2B vector plus 2B vector is 4B vector. So the answer would be 4B vector minus A vector. This should be the answer. And this is when you get it externally. Okay. Similarly, the 12th one is show that the points A, 2I cap minus J cap, I cap minus J cap plus K cap, and B vector I cap minus 3J cap minus 5K cap, and C being 3I cap minus 4J cap minus 4K cap are the vertices of a right angle triangle. So let us find AB. AB will be equal to OB vector minus OA vector. So OB minus OA is minus 3I cap minus 3I cap minus 2J cap minus 6K cap. Similarly, BC vector will be equal to OC vector minus OB vector. So OC vector is 3I cap minus I cap is 2I cap minus J cap minus K cap. So AC vector is going to be equal to OC vector minus OA vector. So OC vector is, so 3 minus 2 is going to give us I cap minus 3J cap minus 5K cap. So from here, if I take the magnitude of AB vector, it will be square root of 9 plus 4 plus 36, which is 7. If I take the magnitude of BC vector, it will be square root of 4 plus 1 plus 1, which will be square root of 6. If I take magnitude of AC vector, it will be square root of 1 plus 9 plus 25, which is going to be root 39. So if I see,
Sir,
tell me.
Sir, in OB vector, isn't it -1 I cap? I mean AB vector.
Where is it? -1 I cap. I made a mistake. Yeah, it is
Sir, it'll
-1.
be I cap minus plus.
So any other mistake? Is it fine? Everything else is fine?
Yes, sir. Yes, sir.
So then it is not 7 here. So then it will be square root of 1 square plus 4 plus 36. It is going to be 41. Square root of 41. 36.
Sir,
Tell me, ma'am.
sir, for that AC vector, it is root 35, right?
1 plus 9, 10, root 35. Now I think we got the answer. That's what I wanted to.
Sir,
Tell me,
sir, a BC vector also it's plus K cap. It's not minus K cap.
BC here. Plus K cap. Fortunately, it is -1 the whole square or +1 the whole square. Yes, K. But I think we have proved it's a right angle triangle because if I see AC square plus BC square, it is coming out to be 35 plus 6, which is 41, which is AB square, which implies AB. That's it. That's enough. So sum of the squares of two sides is equal to the square of the third side. It's a right angle triangle. So where is it right angled? So it is right angled at point C. So it is right angled at point C. So I found it as C because AC square and BC square. So if you take the sum of two squares, whichever point is common, that is a right angle triangle. 1 minute. So now you can start doing the exercise problems. I'll be back. So let us see. Exercise 10.2. Compute the magnitude of the following vectors. Can we? First one answer is root 3. B vector's magnitude is root of 4 plus 49, 53, 53 plus 9, 62, root 62. And C vector's magnitude is 1 by 3 plus 1 by 3 plus 1 by 3. How much is it? 3 by 3, which is going to give us 1. Second, write two different vectors having same magnitude. A vector plus B vector and A vector minus B vector. Right. Write two different vectors having same direction. How will you write? A vector plus B vector. Suppose I give you something like this. Tell me a vector which is having the same direction as this. So when they have same direction, you're talking about the condition of parallelism. So when vectors are parallel or collinear, whatever you call it, one vector is lambda times another. So I can write it as 2 times A vector plus B vector. Okay, A vector plus B vector and 2 times A vector plus B vector. So find the values of x and y so that the vector 2i cap plus 3j cap, 2i cap plus 3j cap is equal to xi cap plus yj cap. So what will be the answer for this? X is 2, y is 3. Fifth one. You find the scalar and the vector components of the vector with initial point 2, 1 and final point as minus 5, 7. So if I take A, it is 2, 1, B is minus 5, 7. So OA vector is 2i cap plus j cap. OB vector is minus 5i cap plus 7j cap. Okay. Now what should we do? Find the scalar and the vector components of the. So if I find out AB vector is how much? Minus 7i cap plus 6j cap. So what are the scalar components? Minus 7, 6. Vector component is the vector itself. Okay. Sixth one. Find the sum of the vectors I cap minus 2j cap. So A vector is I cap minus 2j cap plus k cap. B vector is equal to minus 2i cap plus 4j cap plus 5k cap. And C vector is equal to I cap minus 6j cap minus 7k cap. So A vector plus B vector plus C vector is how much? 0 I cap minus 4j cap minus k cap. Seventh one. Find the unit vector in the direction of A vector is I cap plus j cap plus 2k cap. So I need A cap. So how do I find A cap? A cap is A vector divided by magnitude of A vector, which is going to be I cap plus j cap plus 2k cap divided by magnitude is root of 1 square plus 1 square plus 4. It is I cap plus j cap plus 2k cap divided by square root of 6. Eighth one. Find the unit vector in the direction of PQ vectors where the points P1, 2, 3 and Q is 4, 5, 6. Oh, okay. PQ vector is what I need. So PQ vector is equal to 4 minus 3 is, 4 minus 1 is 3i cap plus 3j cap plus 3k cap. So what are we supposed to find? Find the unit vector in this direction. Let me call this as C vector. So C cap will be equal to C vector divided by magnitude of C vector. So 3i cap plus 3j cap plus 3k cap divided by square root of 9 plus 9 plus 9. So there is going to be 3I cap plus 3J cap plus 3K cap divided by root 27 is 3 root 3. So 3 will cancel all the components. You will get I cap plus J cap plus K cap, the whole divided by root 3. So seventh, we are done with seventh, eighth one system. Okay, let's see the ninth one. For given vectors, A vector, which is 2I cap minus J cap plus 2K cap, and B vector, which is minus I cap plus J cap minus K cap. Find the unit vector in the direction of A vector plus B vector. So A vector plus B vector is equal to I cap plus K cap. Let me call this as C vector. So C cap is equal to C vector divided by magnitude of C vector. That is I cap plus K cap divided by root. Tenth. Find the vector in the direction. So A vector is 5I cap minus J cap plus 2K cap. So we need to find C vector, which is 8 times A cap. So what is A cap? A cap is 5I cap minus J cap plus 2K cap divided by square root of 25 plus 1 plus 4. So this will give us 5I cap minus J cap plus 2K cap, the whole divided by square root of 29. So C vector will be equal to 8 times A cap. So 8 into 5I cap minus J cap plus 2K cap, the whole divided by square root of 29. So this will be the answer. So 11th one, show that the vectors 2I cap minus 3J cap plus 4K cap and minus 4I cap plus 6J cap minus 8K cap are collinear. So if I take A vector, that is going to be 2I cap minus 3J cap plus 4K cap. B vector is equal to, if I take minus 2 outside, it is going to be 2I cap minus 3J cap plus 4K cap. Okay. So A vector is equal to minus 2. Sorry, B vector is minus 2 times A vector. B vector is minus 2 times A vector. If one vector is scalar times another, you can say that the given vectors are collinear. Okay. 12th. See, direction cosines based problem, I'm not going to do it now. I'll explain it in the next chapter. So 12, 13, 14 also I'm leaving. So let's do the 15th one. So if you see the 15th one, find the position vector of R joining the points P and Q, which are given respectively, being divided internally in the ratio 2:1, externally. This one is homework, you can try it. 16th one. Find the position vector of the midpoint of the vector joining 2, 3, 4 and 4, 1, minus 2. So if I take this point as 2, 3, 4, and if I take this point as 4, 1, -2, if this is P, this is Q, if I take this to be R, where this is going to be the midpoint, the ratio will be 1:1. So R will be equal to 2 plus 4 by 2, that is going to be 3, 3 plus 1 by 2, which is going to be 2, 4 minus 2 by 2, which is going to be 1. So OR vector will be equal to 3i cap plus 2j cap plus k cap. Okay, there's the 15th one. 16th is 16th. Oh, 16th we did, no, 17th, sorry. 17th is also homework. It is similar to the example number 12 that we discussed. So look at the 18th one. In a triangle ABC, which of the following is not true? AB vector plus BC vector plus CA vector is 0. That is wrong. Because AB vector plus BC vector is equal to AC vector according to the triangle of addition. So AB vector plus BC vector, if this AC comes to the left hand side, minus AC vector is 0 is right. That is option B is right. Similarly, AB vector plus BC vector minus AC can be written as plus CA using the negative of vector. Minus AC is negative of CA. So AB vector plus BC vector plus, that is also right, sorry. A is right. Similarly, see what is the difference between option B and C? Is there a printing mistake in my book? I'm able to see B and C to be the same. Is it the same with your case also? See, if that is the case, all the options are right. There is nothing like which is wrong. There is a printing mistake in the copy I'm seeing. Okay. Anyways, look at the 19th one. If A vector and B vector are two collinear vectors, then which of the following is incorrect? So if there are two collinear vectors, one vector will be scalar times another. This I've told you. B vector is equal to lambda times A vector, or A vector will be equal to plus or minus B vector. Similarly, the respective components of A and B are not proportional. That is wrong. So option C is wrong. That is incorrect. Because since they are multiplied with the same scalar, the component, the x component on both sides and y component on both sides will be in the same ratio. They are proportional. Here. So this is all about exercise 10.2. Now we'll discuss the product of vectors. So I'm going to discuss about the product of two vectors. So when you talk about the multiplication of two vectors, so we have learned multiplication of a vector with a scalar, that is different from multiplication of a vector with another vector. So when you take a multiplication of one vector with another, there are two kinds of products possible. One is called as scalar and the second is called as the vector. So when I talk about the scalar products, right? So if I take two non-zero vectors, A vector and B vector, let me call them to be the non-zero vectors. If there are two non-zero vectors, A and B, then A vector dot B vector, how do you read it? A vector dot B vector is given as magnitude of A vector into magnitude of B vector into cos of the angle between these two vectors. So cos of the angle between them. Suppose if magnitude of A vector is 0 or magnitude of B vector is 0, then dot product is not defined. Okay. The next question is, when you do the dot product between two vectors, if you observe here, no, when you're doing the dot product between two vectors, the output is there on the right hand side, right? Magnitude of A into magnitude of B into cos theta. This will actually be a number. Number is basically a scalar. So when you do the dot product between two vectors, the output is going to be a scalar. That is why dot product is also known as scalar product, or I can say scalar product is also known as dot product, right? So based on this, if you see, the following observations can be taken into consideration. One is A vector dot B vector is a real number. That is the first point to be noted. Second, if A vector and B vector are two non-zero vectors and A vector dot B vector comes out to be 0, then we can conclude that A vector and B vector are perpendicular to each other. Okay. Thirdly, if theta is equal to 0, right, then A vector dot B vector can be written as magnitude of A vector into magnitude of B vector into cos 0. Cos 0 is going to give us 1. Similarly, if theta is equal to 90 degrees, then A vector dot B vector can be written like this. Can be magnitude of A vector, magnitude of B vector into cos 90. Cos 90 is a 0. That is why the dot product between A vector and B vector will be 0 when the vectors are perpendicular to each other. And this is a very important condition which we'll use to solve many problems. Okay. Similarly, if theta is equal to pi, means if they are anti-parallel vectors, then A vector dot B vector will be equal to magnitude of A vector into magnitude of B vector into cos pi, which will be negative of magnitude of A vector into magnitude of B vector. Right. The most important point to be noted here is, if I cap, J cap, and K cap are the respective orthogonal unit vectors along X, Y, and Z respectively, then I cap dot I cap will be 1, I cap dot J cap will be 0. Similarly, J cap dot J cap will be 1 and K cap dot K cap will also be 1. I dot J is 0, J dot K is 0, and K dot I is 0. Okay. Next is if A vector and B vector are given and you're asked to find the angle between these two vectors, then what we can do is A vector dot B vector will be magnitude of A vector, magnitude of B vector into cos theta, which implies cos theta will be equal to A vector dot B vector by magnitude of A vector into magnitude of B vector. So this is used as a formula to calculate the angle between two non-zero vectors that are given to us. Eighth one is scalar product is commutative in the sense A vector dot B vector is equal to B vector dot A vector. So that is obvious because when I do A dot B, I'll get cos theta. When I do B dot A, I'll get cos of minus theta. We know that cos of minus theta is cos theta. So they both are commutative. Similarly, the other properties, they are distributive also. So distributivity of scalar product, you will have A vector dot B vector plus C vector is equal to A vector dot B vector plus A vector dot C vector. And the last one is if A vector and B vector are two non-zero vectors, then lambda times A vector dot B vector is the same as A vector dot lambda times B vector is the same as lambda times A vector dot B vector. Because that lambda is only a number. Okay. So with these concepts in mind, we can actually solve some problems. So find the angle between A vector and B vector whose magnitudes are 1 and 2. So magnitude of A is 1, magnitude of B is 2, and A dot B is given as 1. So what is the formula? Cos theta is equal to A vector dot B vector by magnitude of A vector into magnitude of B vector. So A dot B is 1 divided by magnitude of A is 1. Here it is 2. Answer will be half. So cos theta is equal to half implies theta is equal to 60 degrees. Or this is also going to be equal to pi by 3 radian. Okay. So next one is So done with example 14. So find the angle between the vectors I cap plus j cap minus k cap and I cap minus j cap plus k cap. So what is cos theta equal to a vector dot b vector by magnitude of a vector into magnitude of b vector. 1 minus 1 minus 1 divided by square root of 3 into square root of 3. Cancel these two. Minus 1 by 3. So theta will be cos inverse of minus 1 by 3. Okay. So example 15 we will see a vector is equal to 5 I cap minus j cap minus 3k cap and b vector is equal to I cap plus 3j cap minus 5k cap. Okay. Show that the vectors are perpendicular. So a vector plus b vector and a vector minus b vector are the vectors. We need to show that they are perpendicular to each other. So what is a vector plus b vector? It is going to be 6I cap plus 2j cap minus 8k cap and a vector minus b vector is 4I cap minus 4j cap plus 2k cap. Okay. So a plus b into a plus b dot a minus b. If you do that, you will get 24 minus 8 minus 16. So this is going to give us 24 minus 24, which will be a 0. Okay, 16. See, projection part I'll explain later. We'll do some simple problems. So 17th. Find magnitude of a vector minus b vector. If the two vectors are such that magnitude of a vector is 2 and magnitude of b vector is 3 and a vector dot b vector is 4. So for these kind of problems, what you're supposed to do is, there is a property, listen to this carefully. So a vector dot a vector will be magnitude of a vector into magnitude of a vector into cos 0. So this will give us magnitude of a vector square. So whenever you want the square of the magnitude of a vector, then do the dot product of the vector with itself. Meaning, if I take a vector minus b vector, then what I will do is, I'll consider this magnitude of a minus b the whole square. That will be a vector minus b vector dot a vector minus b vector. That is going to give us a square plus b square minus 2a vector dot b vector. So a square is 4 plus b square is 9 minus 2 times a vector dot b vector is going to give us 4. So 13 minus 8 is 5. So magnitude of a minus b the whole square is 5. So magnitude of a minus b will be square root of 5. This will be the answer. Okay. Next is 18th. If a vector is a unit vector, a vector is a unit vector and x minus a vector dot x vector plus a vector is 8. Then find magnitude of x vector. So this will be x square minus a square is 8. X square minus 1 is 8, which implies x square is equal to 9 or x is equal to plus or minus 3. Oh, sorry, magnitude of x, no? So magnitude of x can't be negative. So magnitude of x vector will be equal to 3. Let us look at the 19th one. For any two vectors, a vector and b vector, we always have magnitude of a vector dot b vector is less than or equal to magnitude of a vector into magnitude of b vector. This is what we need to prove. Okay. So we know that cos theta is equal to a vector dot b vector by magnitude of a vector into magnitude of b vector, which implies a vector dot b vector is equal to, I'll take magnitude on both the sides. When I take magnitude on both the sides, I get magnitude of cos theta is equal to magnitude of a vector dot b vector divided by magnitude of a vector into magnitude of b vector. So this is less than or equal to 1, which implies magnitude of a vector dot b vector magnitude of a vector dot b vector is less than or equal to magnitude of a vector into magnitude of b vector. I wrote this because cos theta is greater than or equal to minus 1 and less than or equal to 1. This is the same as magnitude of cos theta being less than or equal to 1. Okay. So for today, the homework problems that you need to do are in exercise 10.3, right? In exercise 10.3, you can try out the problems except projection. You can try out the problems which are based on, except the ones which are based on projection and inequality. Everything else you guys can do it. There is no support needed. Okay. So is there any other doubt? Is there any other doubt?
No, sir. No, sir.
No, sir.
Okay, then we'll wind up. See you all tomorrow.
Thank you, sir.
1 minute. Tomorrow, can we have an early class? Maybe around 5:30? Will it work for everyone?
Yes, sir.
Yes, sir.
Okay, tomorrow we'll have from 5:30.
Yes, sir.
Yeah.
So is it from 5:30 to 6:30 or is it till 7?
We'll do maybe 6:45 we'll have, because we can finish cross product. See, cross product, again, I'll send you a video. You can just go through the content part. Problems alone, I'll do it tomorrow. I want to start 3D because 3D will still take some time. So mostly till 6:45 maximum.
Okay, sir.
Yes, sir. Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Yeah.